Good morning, good afternoon, and good evening, depending on where you're joining us from today. My name is Genevieve Cross, and I am the head of a marketing department at StackState, and I am honored to welcome you to today's interactive webinar, which is Kubernetes Troubleshooting in Action, 500 Errors Resolved Faster. Before we get started, though, I want to go over a little bit of housekeeping rules. This presentation is going to be recorded. So just in case you want to rewatch this later on, or you want to share this presentation with your coworkers or your friends, you will have the capability of doing that. We also have a couple of options of engaging with the speakers, which if you look over on your right in the actual GoToWebinar control panel, you'll have the ability to ask questions in which we will answer them, while we're going through it, or actually answer them directly through the Q&A at the end of the webinar. I'd like to welcome Andreas Prinz, who is StackState Chief Product Officer. Welcome, Andreas.
Thank you.
And also I'd like to welcome and introduce Louis Lauder, who is our Director of Engineering, and welcome, Louis.
Thank you.
All right, without further ado, I am passing the baton over to you, Andreas. Thank you.
Yeah, thank you so much, Genevieve, and thanks for joining Louis with us, and thank you all for joining this webinar. In the previous webinar, I don't know if you joined, definitely watching, we talked quite a bit about the different types of data that you need to do troubleshooting, so more kind of a theoretical conversation, I would say. Today, that's going to be entirely different. So at least half of the time, we want to do a demo where Lou will drive us through our product, the latest edition of the product, and where needed, we'll spark into an interesting conversation and try to solve as much issues as possible. I don't know about you, but lately, and I must admit, yesterday in particular, while prepping this webinar, I actually got a 500 error myself. I was using Peerby, which is a platform where you can borrow tools from your neighbors in your neighborhood. And all of a sudden I got a 503 error, and you can imagine the frustration because I was about to use a Vetucute machine. I don't know what the English name is about that. I'll share it later, but I couldn't because the website was simply down. As a business owner, it is super important that you manage these 500 errors, or that you get rid of them, reduce them to a minimum. Why? Because it's disruptive. And that's why solving them makes a lot of sense, and paying attention as much as possible to them when they arise in your landscape is super important. And in this webinar, what we would really like to do is cover kind of the business impact. What is a 500 error real briefly, because if you're in IT, I imagine you know that already by now. If not, we'll go over it at a high level. And then we look a little deeper in how could you actually troubleshoot 500 errors, an important topic. We take a look at what is internet telling us, and more important, what is the SRE handbook telling us on how to solve these type of issues. And then furthermore, one step deeper is what are the common issues that you might face when doing this. And these three topics will introduce us to the demo where Louis will take over and we go much deeper. But before we go there, let's take a close look at the 500 errors itself. So if you take a look, you've heard about it most likely, and I've put a variation of 500 errors here on the right side of the screen. But more important, if you're interacting with a system that has a server component and you're in your browser, whether or not it's your laptop, your local desktop, or your mobile phone, the application can give you quite a bit of different types of errors. And the 500 category are errors that happen on the server, and they're just a subset of the HTTP status codes. They're the 100, 2, 3, and 400 error codes as well. But in particular, the 500 ones are the ones that we need to take a look at, because there's something going on in the interaction between you as a client and the server. And a little bit depending on the specific 500 error you get, the server error, you know already a little bit better what's going on. So as an example, the 500 itself is an internal server error, a generic one. If it's harder to specify what's actually happening, you will get the 500 served. The 501 is you get a wrong HTTP method, so whether or not there's a get, a delete, or whatnot. If it's not being answered in the back, if you like, on the server side, not known, you'll get a 501 error. And then a 503 is also really interesting, primarily interesting if there's an unexpected peak in the traffic going to your system and the system cannot handle it, then you most likely get a 503 error. The server cannot handle the request due to a temporary overload. You see, these three flavors already all have a different root cause. But important, the question, what do they have in common? Or more important probably is, why does it matter from a business perspective? A real brief. As I mentioned, the issue at hand is that a customer using your system has poor access to your server. Simply, his request cannot be executed. And this is more important to pay attention to than you probably imagine. Because the first, and primarily if you're web oriented, the first issue is the negative impact on search engine optimization. If this happens often, Google starts to rank you lower and lower. And if you're in e-commerce, or if you're having any other web customer facing application, this search engine optimization does matter for you. And getting a lower ranking ultimately leads to less leads into your system, less potential users, and ultimately a bad sales result, most likely. The second one, and that's really what I experienced yesterday with that Peerby platform, is it's negative from a customer experience. People get unhappy if this happens. Sometimes it's just a refresh and then it's solved, or you need to wait for half a day until the load on the system is lower. But it isn't that nice because ultimately you as a user are impacted and you don't know actually what to do. Last but not least, what it results is customer churn. Customers ultimately abandoning your business. And that's definitely what we would like to avoid. But now the main question is, if we know what it is, 500 errors, the broader category, a few of the specific ones, and the impact, is how would you solve this? And without looking straight into StackState, I just Googled quickly how to fix 500 server errors. And won't be a surprise if you would do the query yourself on Google. You come up with tens of websites, or probably hundreds of websites, that will tell you on how to do. Check the error log, make sure it's not overloaded, and funny enough, check if there are recent changes made to the system. I will come back to that a little later during the demo. Another one, on crawl, I don't know the website itself, was one of the first results, how to fix 500 errors. Same pattern, reloading, check the error logs, changes, upgrades. So there's something with the load of the system, there's some errors, probably being able to spot in the logs, that's why you need to check the logs. And there is potentially a bigger load on the system that require more accurate analysis of what is actually going on. And then our friend, obviously, ChatGPT, also not a stupid buddy to have in your back pocket, also nicely answers what to do to overcome these 500 errors. Refreshing the page, check to the service status, clear cache and cookies, contact the website administrator, also an interesting one. And last but not least, check the server logs. So the pattern of logs, change, and load is pretty repetitive, and that makes a lot of sense when troubleshooting. So I don't know, what about you, if you're used to troubleshoot these issues already? If not, keep these three in mind when we go in a bit into the demo. And I'm always intrigued by these snippets of advice because they, to me, occur really randomly, right? Do this, do that, check the logs. The question we at StackState ask ourselves, is there a more repetitive or more standardized process, if you like, that is helpful to take a look at solving issues? And then if you're in the cloud native space, you definitely have the site reliability engineering handbook coming into your mind straight away, right? As the magic guide towards a stable and reliable landscape. And I do think one of the most important pieces of the book that describe on how to remediate is this little process. And I'll go over it step by step because it's important to understand in a modern landscape how to do this examining and troubleshooting of issues, ultimately to really remediate the issue. And let's start at the top left. Over here we see the problem report. And the problem report is really, as it states, a report, what can be an Ops Genie or a PagerDuty alert, a Slack message. It can be a notification in any other system, but that will help you to understand what the issue is. And really important, the problem report already documents the most relevant information to start with the triage. So it is actually the start of the process. An issue is reported, and the richer, I would say, your problem report is, yeah, the faster ultimately you can go through this entire process. So we have some data, it's alerted, and then the next step is the triage itself. Because sometimes what is happening, and in particular with 500 errors, 500 errors are the kind of the outer layer what your customers would experience. But it can very well happen that under the hood, there's a sequence of errors happening on various components in your landscape. And to really know where to remediate or where to look at first, you need to do a triage. So if there are multiple signals coming in, what is actually the most important signal that you need to respond to? How does it relate to others? And that is where you need to focus on the most important, most likely issue in your landscape. And then the examine and the diagnose. If you know what it is, or actually if you where it is and where you need to start your triage, then the examine is super important. And often you need to gather more data to really understand if each of the components that is involved is behaving correctly. So you do a kind of a broader, analysis of your pods, your containers, your landscape, really to understand is, hey, this service is failing, but what about the others? Are they behaving correct? Then the third one is to diagnose, analyze the information to determine the cause of the issue. And you really start asking the question, what actually happened? What do I see? What is the data telling me? Where is it happening? On what components? Why? What time? What touch did last? Were there any changes? So all the questions to really build that holistic understanding of that particular component, because it very well might be that you're looking at the symptom of an issue rather than the thing, the cause, and the elements that you need to remediate. So a diagnose often requires some expertise, but more important, requires to have all the data at your fingertips and easily navigate from one component to the other. And Louis will show in the demo how that looks like. And then obviously, if you know what it is, you start testing, validating theories, trying to fix it, test it, and ultimately you implement a permanent solution for this issue. The goal, and that's important to realize if you are working in a more cloud native oriented world, is that doing this cycle frequently and with as much data as possible makes a lot of sense, because ultimately you need to remediate as quick as possible. And don't mix the remediation up with deep root cause analysis. Sometimes, in particular with 500 errors, it is important to remediate, because then your customers will experience a reliable service again before you truly understand what the root cause of the issue was. Imagine you push a change, right? It's better sometimes to roll back than going back into your engineering teams and start asking about test coverage or start asking about code reviews and all these type of things. Fix it first and then do the analysis later. And in the SRE handbook, this is called the postmortem, or if you like, a blameless postmortem. Really important to learn, to develop. If you want to know more about this, please tune in on our previous webinar. There's a recording where we go really deep on learning and blameless postmortems. All right, so this is really the structured issue, but we also asked a question to our customers, and primarily what we do in larger enterprises. Hey, but what are your struggles? I mean, it sounds nice, had to do quick remediation, but what are the challenges that you and your teams are actually facing? And we see 4 of them. The first one is an issue not often happen in isolation, and teams are still hindered by these organizational silos. And where the silos between dev and ops has disappeared and between infra and development are well, nicely merging together, there's still the team silo. So I'm working on a couple of my services, the team next door or next room is working on a couple of other services, and then you actually have your organizational silo back again. So the ability to really identify where it is is still a kind of a struggle. And that's also one of the struggles that we try to solve with StackState, because bringing the data together is super important. The second one is incomplete and outdated documentation. Primarily, if you go, for example, to the CMDB, is it really reflecting your cloud native landscape? And me asking the question is probably answering it. There's so much changing that CMDB as a source of knowing how your system landscape looks like is simply not enough. So knowing how all stuff is related is really important. Then the other one is often there is enough data, but it's not accessible for many engineers in the software development team. So imagine there's a lot of logs being created by containers on your Kubernetes cluster. Do your engineers have easy access to it? And that is important because they need to troubleshoot and they need to see the errors, the warnings in the logs. So overcoming that challenge, we feel is really important, because empowering your engineers to do the troubleshooting will ultimately lower the burden on your platform teams or your SRE teams, who are often asked very frequently to look in these type of things. So there is data, but it's often not accessible for the ones who really need it doing the troubleshooting. And then the last one is the limited expertise. And that is something we think is really important for companies to focus on. Often there are the platform teams again, and the engineer and the SRE teams, site reliability engineering teams, who do have the knowledge. But do your software development teams have this knowledge as well? And how do they cope with difficult issues? So if your observability platform could contain some of this knowledge, that will be really beneficial for your engineering teams. And in the demo, we'll dive there into as well, and Louis will show us how important that is. So that's one, that's the troubleshooting challenge in a large enterprise. And then, and I didn't talk about it yet, there's the other level of complexity. And I don't know how it's going on your side, but where we dreamed about a abstraction of infrastructure is for some teams, and primarily the software engineering teams who deploy to Kubernetes, Kubernetes becoming a kind of a black box or even potentially a monster. There's so much going on. How do you observe it? And I took here a nice image of Gartner, all credits to Gartner, who articulated the different levels or layers, if you like, of monitoring. So all the way here on the left side, we see containers running in pods, and obviously the containers require individual container monitoring. The services require particular service monitoring. The pods also require pod monitoring. So you see already a layer of container, pods, services, and then going even beyond, where we talk about host level, cluster, transactions flowing through the system with primarily trace information. So you see already that it's really that multifaceted view of your Kubernetes cluster that is needed to take care of the cluster, and really important to take care of the application running on the cluster. And that brings the challenge of troubleshooting really to the next level, because if you would only have 500 errors in your application caused by the application and not necessarily by the infra or any other, if there would be a clear split, it would be easy. But troubleshooting an issue is really that mixture of, hey, what is the signal I see? What is the cause of the issue? What really goes wrong? And what is it that I need to remediate to get stuff back in a healthy shape? So that's just for awareness. And then a little bit more simple to summarize before we move over to the demo. If this would be your Kubernetes cluster with a master node and a couple worker nodes with pods, containers running on there, the proxy, the kubelet, a lot of issues, a lot of signals can be shown. But the question is, what is really the cause of the issue? Is that a deployment issue? Is that an unexpected high increase from usage from outside to your platform? Or is it simply that you haven't provisioned enough resources, infra resources, to underpin the nodes, the pods, and all the machinery that runs? And you see, reading signals that come out of this is not as simple as detecting what is actually going wrong. How you're probably used to that is you use a combination of tools. So if you would ask the expert, he would say, yeah, I use kubectl command line to retrieve events from a Kubernetes cluster. I would use Grafana Loki to browse through the logs and detect any errors or warnings. If I would know more about the pod, I would use kubectl again to get the information on the pod. If I want to see the big picture, I have probably dashboards in place to see pod utilization or cluster performance or whatnot. You see there are multiple tools required to answer the question, what are the signals and what are the causes and how do I need to remediate? And that for StackState was really the challenge to say, hey, if this is going on, if our sole purpose is to help companies troubleshoot as fast as possible, to reduce customer churn and to reduce unhappy customers, then what is it that we would like to do? And there are actually 4 things that the StackState platform is bringing you. The first one, it's collecting and correlating all metrics, events, traces, and logs. And I would like to call that out. It's actually democratizing observability data. Rather than leaving it on the cluster and in separate dashboards, it's there for every software developer to use. The second one is all about visualizing service and other resource dependencies, because having the data is one, but knowing in the triage and in the examine, knowing how components relate to each other is super important. That's the second thing that StackState does, and we'll see that in the demo as well. The third one, if you have data, if it's nicely sorted, connected, correlated, then the question is, how do you act upon that? And we've seen in a couple slides ago that one of the challenges is the limited knowledge. So StackState has given itself the challenge that as soon as you take in the data, particular monitors will be fired and will check for common mistakes, including, obviously, the 500 error mistakes, because these are important. And then last but not least, issues are detected, and then the main challenge is how to remediate. And that's also one of the pieces that I would like to ask Louis to demo. And with having said that, the word is up to you, Louis.
Thank you, Andreas. Hello, everyone. I'm thrilled to present StackState, a powerful solution specifically tailored for developers and site reliability engineers who work with Kubernetes-based applications. Our aim with this demonstration is to show how StackState can help you to troubleshoot with HTTP 500 responses effectively within your Kubernetes environments. During this demo, we'll explore some of StackState's key features, which include instant issue detection and swift navigation, effective guided troubleshooting, comprehensive visualization of golden signals and Kubernetes resources, automatic discovery and mapping of Kubernetes dependencies, and a complete service map. One of the biggest challenges when working with Kubernetes is detecting and remediating issues as they arise. StackState addresses this challenge by providing pre-configured best practice-based monitors that help you identify problems right away. One such predefined monitor you'll encounter when using StackState is the HTTP 500 error ratio monitor. With this monitor, StackState will detect, alert, and then offer guided remediation, enabling you to quickly identify the root cause. To better illustrate how this works, let's look at a simulated Kubernetes environment where we've encountered an issue. StackState's main navigation menu will show you links to overview screens for all the main Kubernetes component types. In addition to that, we have an advanced feature for saved views and a variety of other features at the bottom. Let's start at the metrics screen. Most of our monitors rely on metrics data streamed to us from our StackState agent installed in the Kubernetes cluster being monitored. These agents are easy to install and collect a wealth of information. This screen is really useful when you are exploring all the metrics available for your cluster. The 500 error ratio monitor relies on the endpoint HTTP requests count metric. As you can see, this metric is a counter. It constantly increases over time. Now, because StackState uses a highly scalable Prometheus-compatible metric store, we have full access to using PromQL, a language you might be familiar with if you've been using Grafana and Prometheus. In this case, we probably want to apply the aggregation called rate to this metric. If you do this, you can see the rate at which the number of requests are increasing against the various components in your system. To narrow this to just being 500 errors, we need to say, okay, we want the code to be 500. In addition, this has to be normalized against the total number of request responses. At this point, the PromQL query can also become a bit complicated. I have a pre-saved one because I don't want to type it in right now that you can see here. This is quite a complicated PromQL query, but it shows you the full power of exploring the metrics and everything you can do in our system. Everything you can do in Grafana or any other Prometheus-compatible metric store can be done through StackState. Luckily, a query like this can be built once and then used in a monitor, like the HTTP 500 error monitor that comes built in with your StackState deployment. Let's switch to the monitor screen to see this in action. Your StackState service comes with an expanding number of highly scalable monitors that apply intelligence to the metrics for your cluster. These monitors will alert you when your Kubernetes components like services and pods start misbehaving. Let's take a closer look at the HTTP 500 error ratio monitor. Our monitors are highly configurable. Here you can see some of the configuration, like the threshold, the time window over which it operates, the interval, which is how frequently it runs, and an identifier that shows you where that complicated metrics query that I was showing you before is being stored and run. Behind the scenes, this monitor is using the metrics query we explored earlier and creates an alert for any component for which the metrics goes outside the prescribed bounds. This screen is really useful to get a high-level overview of what monitors are running in your system and how many components they apply to. StackState comes shipped with 9 of them, but they are ever increasing as we find more use cases for our monitors.
And then just for me to understand, Louis, the first part that you were showing, the metric screen,
yeah,
that is then really the data ingestion. So that's still kind of the raw data that comes into the platform.
Yes.
And then the second step, what you need to do is, okay, data is nice, but then you continuously want to validate how it's behaving, and that's what the monitors then bring.
Exactly. If you look at this monitor definition, there's a threshold of 0.05, which means basically if more than 5% of your responses is 500,
yeah,
this monitor will start complaining and alert you. And if you look,
and other monitors can have other thresholds and will check other metrics that come into the system.
Exactly. And if you look on this overview page, you can see for all of these monitors how many components is currently in a clear state and in a deviating state based on those thresholds.
Yeah.
Next, I would like to show you the service overview screen.
Before you go there, can you elaborate a little bit on what we just noticed in the menu? What are these? Because I see a lot of.
Yeah. So we have Kubernetes as a top level selection here, and then we have all of the standard component types that you see in Kubernetes. You have services, pods, deployments, stateful sets, daemon sets, nodes, persistent volume claims and persistent volumes. Now, depending on your level of understanding of Kubernetes, these will be very familiar to you or not. But what you need to understand is all of these are important parts of what makes Kubernetes work. And depending on the kind of alert or the kind of monitor that you have, you might go to different places to investigate. Today, I would like to start at services. It's already there. For this demo, we are using a standard Kubernetes demo application called SockShop. We made some modifications to this application that causes it to have problems on some of its components that we can then detect using StackState. These problems cycle over an hour. Let's limit the namespace to this application. One of the amazing features of StackState is that we hold onto the state, metrics, events, logs, and service map of your application for each point in time. This means we can investigate issues live, but we can also travel back in time to the point where an issue occurred and investigate what happened. I will now look for a point in time when the SockShop was having problems. Let's set the time travel to show us the last 6 hours. And let's search a little bit. Last time I checked, 1530 had that, but it is not like that at the moment. Just give me a second. Yeah, I found at the point in time where the system is clearly having issues. As you can see, the top 4 services are having problems. It's not clear yet what is causing it, and because we have 4 services in a deviating state, I'm not sure which one should be the first to be investigated. When this is the case, the topology perspective can be really useful. Here you can see one of StackState's most powerful features. By simply installing the StackState agent into your cluster, the full enriched service map is automatically generated with no manual effort required. This service map is a living document that gives you insight into the state of your production system and the relationships between components. Let's explore one of these connections. Let's look at the one between the front end and catalog. Here you can see the way the front end service is connected to the catalog. Through the front end pod, through the front end container, and the server, the actual process, and on the process level, it's talking to the catalog service. From the screen, it is clear that the ingress and front-end services depend on the catalog service. So let's start our investigation there. Something else that I want to highlight is that our agent uses a protocol called eBPF. It's a platform on which it is built that collects all of this information, all of the metrics, all of the information you need to build this topology. It's all been collected by simply installing the agent, and this will happen completely automatically. You don't have to do any custom work. This is a living document that shows the latest state of your system. So let's dive into the catalog service. This screen gives you a full overview of the service you are investigating. All the most useful static information is accessible here and on the show configuration pop-up. We have the static information at the top left. If we click here on the left show configuration, you can see the YAML file that describes the configuration of the service. In addition, you can see the active monitors that are currently watching this component and their state. They are all deviating. And the first 3 of the 4 golden signals the SRE handbook has taught us to value: the error rate, the throughput, and the latency. They are all visible here. You should be able to see the cyclical nature of the metrics on the SockShop demo application, as the issue that is regularly introduced and then resolved at a regular cadence. We can see that the HTTP 500 error ratio monitor is currently alerting. Let's open it and take a closer look. At the top, you get a description that tells you what this monitor is about. The current state, health state for it, which is deviating. Then again, the chart showing the ratio of 500 responses to total responses. This is the same data that I showed you at the very beginning of this presentation on the metric screen, but applied to this specific component. Previously, it was showing a range of different components. Now it's on this very specific catalog service component. Next, we have related open health violations. This is a really useful part of the monitor because it shows us that for this component, the relationship of other monitors that's failing in our system and how closely related they are to this component. The first two shows the monitors that's failing exactly on this component. The next one shows the pod that this service uses to deliver its services, and then other services further removed. Let's take a closer look at the troubleshooting steps.
And before you go on there, so StackState is able to come up with this understanding because of the what you call the dynamic or extensive service map, right?
Yes.
The topology we've seen, and therefore we can say, hey, this is how the different elements relate to each other, and also then where you need to look at more carefully. Is that correct?
Yes, exactly. So this is all inferred automatically, and it's dynamic depending on other monitors failing in your system, the health state of your components. Every time you look at this monitor, it will show you what's happening right now, and you can investigate and dive into this.
Yeah.
In the beginning, when you start using StackState, you will probably read these suggested troubleshooting steps quite a bit. Andreas referred to the fact that we want to put some of the knowledge, the standard knowledge that's out there about how we troubleshoot certain conditions for our applications into our product. And this is where we have done that. In the future, we would like to extend this to be a bit more ambitious and navigate you between the screens and guide you. But at the moment, we have this as troubleshooting steps and some text that you need to read and then follow the instructions. This monitor tells us that the first thing you should look at is if this service is having trouble, it could be because a service it depends on is having trouble, and maybe you should investigate that service. In this case, we jumped straight to the catalog service using the topology screen, and we know that it's at the bottom of the hierarchy of services in terms of their dependencies to each other. So the first step is probably not going to give us any results. The second step says, okay, now look at the pod that the service is built on. Is that one having any issues? And we can clearly see here that catalog 64FB is a pod that has having problems with restarting for containers. So we should probably investigate that pod next. So let's go there.
And before you continue, if you can flip one time back to the previous screen,
yeah.
And close this drawer for a bit. What I would like to connect back to my story, if you talk about triage, understanding what's going on, what Louis did intuitively, he used the topology to assess, hey, how do components relate? That's a way of triaging. On the topology overview, you saw already little dots with a number in it, the amount of alerts, and then here automatically we do a triage again, and we see 3 errors being popping up, and then looking into one specifically to assess if that's the case, or diving into the other. So StackState is there to help you really quickly triage by bringing you the information into your face, by bringing the context. And that's really what we believe important. To triage, you need to know context. And the map, as well as this listing, is then super powerful to build that understanding.
Yeah. Something to understand is, yes, 3 different monitors failing here. But because the root cause that we will get to later is the same thing, if you open up one of these other ones, the same pod will show, because it's that pod that is causing problems, that is giving this service problems. So having errors and having high response time, which is high latency, it's all related to the same root cause. So yes, if it seemed arbitrary me picking this one, it quite frequently does not matter that much. It will drive you to the root cause most of the time.
So what I said in my introduction there, the 500 errors are just a kind of the outer layer of issues that the customer will experience, but most likely under the hood there are other problems going on, and you're saying, yeah, in this case I would come anyhow to that particular failing pod, because that's the deeper issue of causing a bunch of signals that are detected.
Yeah, and you can also see it in terms of the latency and the error rate. As I've said before, we are inducing the problems because this is a demo scenario.
I get it.
And we're doing that at a regular cadence. So you can see here, when we're inducing those problems, the error rate and the latency are both going up, and it's clearly visible through the metrics and the monitors failing. So let's go to the pod. So the pod also have two monitors. The first one says restarts for containers. If you look on the left, you can see all of the, also once again, static information about this pod. It can be very useful when you are, apologies, our lights have turned off. Yeah, there it goes.
That's the proof that it's a live demo, right? If the lights go off.
All of the static information at the top left. We have quite a few buttons here in the middle where you can explore more information about this, and we'll come back to this later, but I would want to just like to show the show configuration again. So a lot of the static information that if you use the Kubernetes and you work with this a lot, this is super useful information to have instantly available. You don't have to go and use your other command line Kubernetes tools to see this information. At the bottom left, you can see, once again, related resources. And in the middle here is events that we are picking up from the container running inside of this pod. And as you can see, it's having problems. It's unhealthy, it runs out of memory, it backs off for a while, it gets killed again. It's not starting up successfully. And to try and understand why, let's see if this monitor can help us with that. At the top, it tells us, it is important to monitor the restarts for each container in a Kubernetes cluster. Containers can restart for a variety of reasons. So it's giving us an overview of what this monitor is looking out for. In this case, because we are currently on our timeline, I've selected a 6-hour period, but this pod has only been alive for this amount of time. We only see data here. We see this table again, but now because we are at the root cause, we can see this is the impacted, this is directly on this guy. This is happening, it's a direct neighbor. It's not, because we're already at the root, this is not the most useful thing anymore. But we get to the suggested troubleshooting steps, and it tells us, look at the pod events, we've already done that. We can see it's trying to start up, it keeps running out of memory. The next it tells us is to look at the container logs for any explicit errors or warnings. So let's do that. So this is another powerful feature of StackState. We integrate all of the observability data that you need to investigate issues, and that includes logs. As you can see, once again, all of the activity here is clustered around this period of time that the pod has been alive. We can see if we can find any errors using the full text search. We do see 2 errors, but they seem very generic, saying it's failed to execute the request within 5 seconds. So this means, yes, we saw that there were memory problems. So probably it was running out of memory. It's trying to serve the request and it just runs out of time, but it doesn't tell us anything about why it might be running out of memory. So yeah, we need to look at something else. The logs won't be the thing that helps us in this case. But quite frequently on other issues, the logs gives you the answer. It's what you should be looking at. So what is the next step according to the troubleshooting steps? Look at the pod age to identify any recent deployments that might have caused the issue. If the pod age is shown at the left of the screen, and it also tells us to look at recent deployments. So we can see at this point in time, the pod was 14 minutes old, and it never started up successfully. So the last deployment might tell us something. This is also a really useful feature. You can see the last deployment made, all of the changes made as part of the deployment. And here we can see, oh, the WeWorks demo, that's the demo app that we're using, has been upgraded from version 0.35 to version 0.36. Quite frequently in your production systems, when stuff goes wrong, it will be related to changes made. It's by far one of the most common causes. So in this case, it's clear that this change was introduced. The change caused this pod to be, the previous pods to be brought down and new pods to be created for this service. And now the pods are not starting up successfully. So something is wrong with this version of the software. And that's where an observability tool will not be able to help you any further. You will have to say, okay, a new code change has occurred. You have to take it up with your team, figure out why was this change made, how was it tested, do we need to roll back, as Andreas described previously. That's probably going to be your first option, and then you need to investigate further what went wrong, etc. I think that's it from my side.
Yeah, thanks. Just to summarize a little bit what we're looking at here, Louis. I mentioned in my slides that you use various tools to gather the data and to assess the situation. And you would use, probably you're now pointing to the event section. You would use kubectl to fetch the events. Events are short-lived in the Kubernetes cluster, so they might already be gone. So you don't have the answers. At the left side, we see logs. I mentioned the log button, if you could click it once more. I mentioned Grafana, Loki, or other log analysis, logs.io, or other logs tools. Then the config and the status that we pull from the cluster as well. In the other two buttons, the status and the config. Also kubectl most likely. And then all the graphs, the charts that you've seen on the, also here, we see CPU usage, throttling, and memory usage.
Yeah, I actually forgot to mention that. So that's the fourth of the SRE handbook golden signals, saturation of your service, of your pods. And yeah, as you can see, I probably should zoom in a little bit there and to that time period. And then you can clearly see, the CPU usage and the memory usage. And here you can see the memory going up. And then, it's been killed. Then that's kind of the problem.
Yeah. And so we have all different types of data, but really brought together. And the beauty, what I think is the beauty of StackState, is that literally every engineer, they can now start doing the troubleshooting because the data is accessible. Second, the monitors are out of the box delivered. And then the guided remediation, in particular, if you're not so used to troubleshooting apps on Kubernetes, are super helpful. Just they point you into the direction that you need to go. So thanks a lot for the demo. Genevieve, if you can make me presenter again, then we can wrap up. And really important, share a really cool update. There we go, with you guys. So we've seen the errors potentially harmful for your business. We've seen that various data types need to be combined to really give that holistic picture, and in StackState add an additional layer, that topology, to really understand what's going on. And then the guided remediation, we believe, and we've heard from many of our customers, is really a kind of the missing link to make your development teams really powerful in troubleshooting. StackState does that already for quite a couple of years, and quite a bit of customers are happy with what we're doing, increasing reliability, and really pushing that to the next level. So that brings me to the final slide. If you're looking forward to use this as well, there are actually two ways to engage. One, everything that Louis was doing, you can do that yourself at play.stackstate.com. So go to play.stackstate.com, and there's an extensive playground, or you go to the homepage and then you see the Explore Playground button, where the majority of the screens, the demo scenario equally runs. And you need to know that this is, yes, the demo scenario is man-made. We fire it every hour. But all the screens, the monitors, the remediation hints are all out of the box. So as soon as you flip it on, you get this. And that's important to get up to speed really rapidly compared to building your Grafana dashboards, for example, and setting your Prometheus alerts. If you're excited and you want to learn more, there is a 14-day free trial. And if it's so exciting, we can absolutely extend that with a week, or even more if you need. But we're really excited to well, to talk with you about this troubleshooting. And if you have other patterns that need to be detected, yeah, let us know, and we're happy to extend. With having said that, there's still a couple minutes left, 5-6 minutes for some questions. So, Lisa, are there any questions, or Genevieve, any questions coming in? You're muted.
You're muted.
Can you hear me now?
Yeah.
Loud and clear.
Excellent, excellent. All right, so we do have a few questions from the audience, Andreas and Louis. So the first one is, which protocol does the agent use to communicate? Is this proprietary to StackState?
Communicate to us. I think it's just basic HTTP, encrypted HTTP. I think maybe behind the question is more, how does it actually gather this information? I would guess like it's using it's an open format called eBPF. It's like a Linux kernel extension that allows you to look at what's happening on the cluster, on the nodes at a low level. It's something you have to install as a daemon set into your cluster. But I don't think in terms of protocols itself that it uses to communicate there's anything novel there. We just send all of that data to Kafka and we process the information.
Yeah. And two things to add, probably slightly related. You mentioned eBPF, and then there's PromQL. So the way how Prometheus scrapes the metrics and gets them in, we do exactly the same. And then through PromQL, you can query them. And then there's a little bit of open telemetry, open metrics to get some additional metrics in, not necessarily ones that we've shown here, but the wider StackState platform.
Yeah, and the agent also scrapes all the logs from your pods and so on and forwards that to us as well. And all the events is also gathered.
Yeah.
Great. All right, so for the next question is, does StackState also detect issues beside 500 errors? And what are they?
The answer is yes. We've now in the demo primarily focused on the 500 errors. I don't know if you can quickly open the monitor page once more. Some of the people might have seen it already, but on that monitor page, yeah, we see quite a bit of the most common failure mistakes.
Yeah, so it's out of memory. I think that showed up a little bit as well.
Can you?
I made you the presenter, yeah.
So we have out of memory, which is it showed up a little bit during the demo. Then if containers keeps restarting, that also showed up during the demo. Available service endpoints, which is purely, are the endpoints on your service available at all? Are they up or not? Kubernetes volume usage trend over the last 4 days. So this is warning you, are you probably going to run out of space on your volume? If so, it will alert you for that. And similar over the last 12 hours. So I think it's just a slightly different perspective of that. Replica set desired replicas. I'm actually not that familiar with that one. I don't know if you know more about it. But these two, the desired replica stateful set and replica set, will tell you if what you've like when you declare what you want in your cluster, you will say, I want this many replicas in my replica set and this many in my stateful set. Now, if those aren't matching, if you don't actually have the number that you said you would want, then these monitors will trigger. And then latency, the response time. Now, we are working on quite a few more and expect this to rapidly expand over the next few months.
Yeah, probably also important to mention is most of our customers expand it themselves as well.
Yes.
So out of the box, you have the most common patterns, but if you're a site reliability engineer, you want to expand it yourself, it's all YAML based. You've seen the definitions, how relatively easy it is, and you can extend it yourself. And that will then, and that's really important, the definition contain also the troubleshooting steps. So the alert or the monitor drawers that Louis was showing, at the top you notice the description, at the bottom the guided remediation steps, and these two go hand in hand with the monitor. So each monitor is the metric, then the rule applied on top of it, and then if it fires, it also helps you to troubleshoot, and that goes into a package. So as an SRE, you can really package the knowledge that you have and make it available for the engineering teams in your company.
Great. So we have a few more questions that have came in. That is, the next one is, what strengths would you say are exclusive to StackState? and then it makes it outstand. Let me read it again. What strengths would you say are exclusive to StackState that makes it stand out from its competitors?
Well, first and foremost, it's the context that we provide, and context is visible literally at every screen except, well, then this admin type of screen. But if you would go to the services page, the highlight page, we bring you context everywhere. So the context is the topology, so having that service map. The context is if you would open a detail page, that you'll see the charts, and you not just see the charts, you see the data that matters for that particular service. And people say, hey, but it's also possible in Grafana. It is. However, this is brought by you automatically. So wherever you go, the system applies it this way. The other really unique, I believe, is how we shape the data that you need for troubleshooting. And then in particular, the pod page is a brilliant example where logs, events, metrics all come together at the highlight pages without being overwhelming. And that's the beauty. Yeah. So for most people, we're looking here at 3-4 tools at the same time. You're looking here at kubectl, at Loki, at Grafana, at whatever tool, and bringing that together in a digestible way is really the power for software engineering teams who want to work with that.
Yeah, and if I can add to that, we barely scratched what the topology can do.
True.
Like I've never worked with another tool that has the ability to, like, I showed the service topology, but you can look at the pod topology. Now it's showing you how all of the pods in this specific namespace are communicating with each other. Now, and normally you would have architecture diagrams and they would always get out of date, and every time a change is made, you have to update those. But this is a living document. It shows you exactly. So as an engineer, I find the hardest part when trying to like adjust to a new work environment or a new product that I'm working on, like what is the structure? How is this thing? And normally people create all kinds of diagrams and you have to go and read through them. But this is all in the tool. It shows you live, oh, this pod is currently having problems. So that's probably why these other ones are having problems. All of that is surfaced so effortlessly, and you don't have to do anything to get this. You just install the agent and it's there.
Yeah.
I think that's really strong.
And also related to that, at least related to that topic, Louis, we had another person ask, does StackState show the underlying platform topology? For example, if the issues is related to the node rather than the application.
Yes. So what we didn't do here is click all the plus buttons. So if you stick in the topology, you could start expanding to the bottom and higher up. And we go here already compute. I don't know exactly what I'm looking at, but then that can click.
Yeah, that's a node.
One deeper. Oh, that's a node already. So there you go. That's the answer to your question. So everything is connected. And that is in particular powerful. If we talk about under provisioning stuff or bigger issues happening, multiple stuff running on a single node, then these topologies are really powerful. There are also highlight pages for nodes, if I'm not mistaken, that bring you to the node page. No monitors yet fired, no events, but still, again, the most important metrics are shown in your face. And then I really like these top 5 resource metrics. Where we take a look at, hey, what are the services running here? And where do you need to take action? And then we clearly see that orange monster is taking quite a bit. So that's another angle of crunching the data.
All right, and I know we have 1 minute left, so maybe we can answer in 1 minute. But the last question is, what is the pricing model? Is it based on what number of pods?
Yeah, the pricing is based on the number of nodes and then pods, or in our case, containers running in it. So if you would go to stackstate.com/pricing, you see the exact price, but there's a fee per node, and then there are 20 containers included, and then additional containers costing $1 per month additionally. So that's on the pricing page. Probably someone can share it in the chat.
All right, so with that question, that concludes today's interactive webinar. I want to say a big thank you, to you, Andreas, and also to you, Louis, for demoing and talking about how our customers and clients can actually troubleshoot their 500 errors.
Excellent. Thank you so much.
Thank you.
Thanks for joining.
Bye-bye.
Cheers.